So now that we're talking about the sun, earth, and moon, we can now start talking about eclipses. So an eclipse occurs when the shadow of An eclipse occurs when we have the sun, moon, and earth line up so that the shadow of the moon or the earth then falls onto the other one. Okay, so it's all about how it is that they're lining up so that shadows are now in play. Now, there are two broad categories for eclipses. There are solar eclipses and lunar eclipses, and we're going to start with lunar. So lunar eclipses occur when the Earth's shadow falls on the moon. So with that understanding, what phase does the moon have to be in to get a lunar eclipse? I hope that you're thinking full, because only during a full moon will it be sun, earth, and then moon, so that the Earth's shadow falls onto the moon. So we can only get lunar eclipses during full moon. Now there are three types of lunar eclipses: penumbral, partial, and total. And to understand the difference between them, we have to understand a little bit about shadows. And so when looking at a shadow, there's actually two different parts of a shadow. There is the umbra, which is actually the very darkest part of the shadow. If you're standing in the umbra of a shadow, then the light source, whatever is creating the light, is actually completely blocked from your view. This is the umbra. It's the deepest, darkest part of the shadow. Surrounding the umbra is the penumbra. The penumbra is the transition from the darkest region to where it is fully light. You're now completely out of shadow. If you're standing with the penumbra, then the light source is only partially blocked. Okay, so some of it's blocked, but not all of it's blocked. So some of the light is being blocked. Okay, so we have the umbra, that's the darkest part, where all of the light source is blocked. And then we have the penumbra, that is the transition from dark to light, where only some of the light source is blocked. And then outside the shadow, the light source is not blocked at all. Okay, so a total lunar eclipse occurs when the moon passes completely through the umbra of the Earth's shadow. So if you were standing on the moon during a total lunar eclipse, you would see the Earth completely block the sun. Now, we are not on the moon, we're on the Earth. Well, probably, maybe some point in the future if somebody's watching this, you aren't, but I'm going to assume that for at least right now, this is the case. Okay, so what we see is the moon completely pass into the Earth's shadow and become much darker. Now, total lunar eclipses are also sometimes referred to as blood moons because the moon appears to go a deep, dark red. Now, I just said that the light source becomes completely blocked, so it seems like the moon should actually go black. But the Earth has an atmosphere. Okay, so the same reason why the sunset is red, this causes reddish light to actually pass through the atmosphere and bend, so some of that red light actually strikes the moon. Okay, we'll talk exactly why we have red sunsets later, but it's that red light falling on the moon that gives it that reddish color, which is why we sometimes refer to it as a blood moon. Okay, so that was a total lunar eclipse. Okay, next we have the partial eclipse. The partial eclipse occurs when the moon is part in the umbra and part in the penumbra. Okay, this is a partial lunar eclipse. Then our last category is the penumbral eclipse. The penumbral eclipse occurs when the moon only goes through the penumbra of the Earth's shadow. So it appears slightly darker, but not all that much. Lunar eclipses aren't terribly uncommon. The Earth's shadow is actually quite large compared to the moon. Okay, so hopefully you've seen one, and if not, then I have no doubt in the next 5 or so years, we're probably going to get another lunar eclipse. Okay, so that was lunar eclipses. Now on to solar eclipses. A solar eclipse occurs when the moon's shadow falls onto the Earth. Okay, so what phase do we have to be in for a solar eclipse to occur? I hope you're thinking new moon. We can only get a solar eclipse during new moon. Now, just like there were 3 different types of lunar eclipse, there are also 3 different types of solar eclipse. There is total, partial, and annular. Now, I love this sequence of images. So here, this is a picture from space of the Earth. Notice, here we've got North America. And here we have the shadow of the moon out in the Pacific. And then as we progress through, we can actually see the shifting of the moon's shadow. We have images of solar eclipses from space, which is freaking awesome. Anyway, so a total eclipse occurs when, from our point of view, the moon completely blocks the sun. So, what part of a shadow are you standing in if you see a total solar eclipse? I hope you're thinking umbra. Okay, so you'll be in the umbra of the moon's shadow if you see a total solar eclipse. Now, if you remember back a couple of years ago, there was what has been sometimes referred to as the Great American Eclipse, where we had a total solar eclipse that actually stretched across the entire continental U.S. Personally, I didn't get to go and actually see totality. That's where you actually see the sun completely blocked. Things happened. It's a sad time. But we'll talk about it in just a little bit. We actually have another one coming up in a few years. So totality is this time where the sun is completely blocked. Now, totality will actually last for a couple of minutes. At its longest, it's somewhere around 6 to 7 minutes long. The one that happened a few years ago, at maximum, was just about 2.5 minutes. Now, during totality, the surface of the sun is blocked, and this allows us to actually start to see other features of the sun that we can't normally see. For example, the corona. We know that the corona of the sun exists because of total solar eclipses. Another of our types of solar eclipse are the annular eclipse. An annular eclipse occurs when the moon crosses in front of the sun, but it doesn't completely block the surface of the sun. Now this happens because the moon is on an elliptical orbit around the Earth. What this means is that sometimes the moon is closer, meaning that it's going to appear larger in the sky, and sometimes it's farther away, so it appears slightly smaller in the sky. If we get a solar eclipse during this time where the moon is farther away, it's actually not large enough to completely block the sun. So we get a ring of sunlight surrounding the moon. This is an annular eclipse. If you are familiar with Spanish or possibly Latin, anillo is how you say ring in Spanish, and annulus is ring in Latin. So annular is a ring of the sun. So hopefully that helps you kind of cement that in your mind. Our last type of eclipse is the partial solar eclipse. A partial solar eclipse occurs where the moon just blocks part of the sun's surface. So, if you see a partial solar eclipse, what part of the moon's shadow are you standing in? You're standing in the penumbra. So, if you are like me and you were not able to go actually see totality during the Great American Eclipse, you got a partial eclipse. And it was still good, it just wasn't as super amazing spectacular as actually getting to see totality. So in this image, we're actually looking at the different regions of totality for different solar eclipses. So for example, this one in August 21st of 2017, this was the Great American Eclipse, the one that just happened a few years ago. Now the one that's going to be happening in a few years is this one in 2024, which again is actually crossing through most of North America. Something that's kind of fun is that this one is actually happening on my wife's birthday. So we get to go see an eclipse on my wife's birthday. I'm super excited about this. I'm really hoping that things don't fall apart like they did the last time. Anyway, so each of these is actually the line of totality. So on that given day at the right time, if you're in one of those regions, you'll be able to see a total solar eclipse. Now, we mentioned that we can get the right alignment during full moon for a lunar eclipse and new moon for a solar eclipse. However, you've probably noticed that we don't have an eclipse every full moon and every new moon. This is because the orbit of the moon is tilted compared to the orbit of the Earth around the Sun. So in this diagram, the blue is the ecliptic plane, okay, or the plane of the ecliptic. This is the path of the Earth around the Sun. This kind of orangey colored one, this is the plane of the moon's orbit around the Earth, and notice it's actually shifted by about 5 degrees. What this means is sometimes the moon is too high and the shadows don't line up, and sometimes the moon is too low and the shadow doesn't line up. Okay, where the two planes meet, where the plane of the ecliptic and the plane of the moon's orbit meet, this is what we refer to as the line of nodes. So for us to actually get an eclipse, the moon doesn't just have to be in the right phase, it must also be in the right place in its orbit. The moon has to be on the line of nodes. So what this means is that eclipses are somewhat uncommon. They're not super uncommon. We get a couple of lunar eclipses every year and a couple of solar eclipses every year. But for us to actually be able to see a lunar or solar eclipse, we have to have the sun, Earth, and moon in not just the right phase, but in the right place in their orbit. Okay, so for example, here we've got the right phase. We have new moon or full moon, but the moon is in the wrong place on its orbit. It is not on the line of nodes, so the shadows aren't lining up. Okay, so we have to have the right phase, and we have to have the right place in the orbit, then the shadows line up, and we get the eclipses. Now, because of the way that the Earth goes around the Sun and the moon goes around the Earth, we actually get a repeating cycle of phases. This is what is known as the Saros cycle, and we get the exact same alignment of the Sun, Earth, and Moon every 18 years, 11 and 1/3 days. Okay, now this doesn't mean we only get eclipses every 18 years, 11 and 1/3 days. It means that we get the same type of eclipse every 18 years, 11 and 1/3 days. Okay, so going back to this diagram, looking at the regions of totality. So looking at this line in 2017, this was the Great American Eclipse, okay, and notice it's orange. In 18 years, we get the exact same eclipse again, okay, where everything's lining up. Notice that it's at about the same latitude. Now it has been shifted east or west, depending on how you view it, okay, because of that extra 1/3 day. But in 18 years, so 2017 plus 18 is 2035, there we have the other eclipse again. Okay, so looking down here, we have an eclipse in 2021, so in just a little while down here, and we're going to get the exact same eclipse in 18 years, in 2039. Okay, so this is the Saros cycle. All right. So here's our 5th clicker question. If eclipses occur when the Sun, Moon, and Earth line up, why don't we have a lunar eclipse each full moon and a solar eclipse each new moon? A, due to the tilt of the orbit of the moon compared to the ecliptic, the shadows don't line up. B, due to the tilt of the Earth, the shadows don't line up. Or C, there is an eclipse each full moon and new moon, just at different locations on the Earth. Go ahead and think about it, and we'll discuss in just a bit. Alright, so why don't we have a lunar eclipse each full moon and a solar eclipse each new moon? It is A. It's because of the tilt of the orbits compared to each other. The moon and the Earth do not orbit around in the same plane. The moon is actually tilted by about 5 degrees. So the correct answer is A.